Welcome to the TALL classes, Technology for All, TALL, TALL, remember. And since you people are new to this format and this class, I will remind you in every class that please keep your mobile phone switched on so that we can interact, and the mobile phone number where you have to connect 9818951003. So this is the phone where you can enter into WhatsApp chat and you can ask as many questions as you want, and we will answer those questions. Like every day, today's class also, we start with a small prayer praising the eternal Guru. For the Guru, the Almighty, is not only the creator but our ultimate teacher.
Gurur Brahma Gurur Vishnu Gurur Devo Maheshwara Gurur Sakshat Parabrahma Tasmai Shri Guruve Namaha Tasmai Shri Guruve Namaha Tasmai Shri Guruve Namaha.
In the last class, we had asked one question based on your questions. Who should attend this class? And we had responded that all technology users, all those who use computers, smartphones and internet should attend this class. Whether you attend the free part, which is of 10 minutes, or you attend the paid part, which is of 45 minutes, you must keep yourself abreast with the technology which is taking place today and which is so omnipresent in our lives. Unless you do that, you will soon find yourself a relic, a dinosaur, and somebody who does not know the basic way to conduct yourself in the futuristic world. So all those who use computers, smartphones and internet, there is almost over 5 billion of the world's citizens, learn with technology, and you should learn from Technology for All classes because it is simple. We try to bring you these classes in a readable format, in an easily digestible format, in a story format, so that you come to know about technology through storytelling. So this is something which we are trying to bring to you, and you will definitely gain. Maybe it is not as interesting as seeing a comic video or watching a movie, but it is very useful to you. So please keep on seeing this, even if it's the free version. Now we will tell you something that what we had taught in the last class. We will start with that and then we will proceed. So we had explained to you how the internet came, and the internet came because the US had lost in the Vietnam War, and the US Army heads wanted a communication system to be developed so that the soldiers on the ground over there could communicate with the headquarters at Pentagon. So that communication could only happen if computers could communicate with each other. So the challenge was to make computers communicate. So in the mid-70s, after the Vietnam War, the US wanted the computers to communicate with each other over long distances. So it engaged a few scientists, half a dozen scientists at Menlo Park, and it tried to do that experiment. But although the data packets which were uploaded were transmitted very easily through radio waves, what happened was after downloading the data, it could not be easily transferable from computer to computer, and that took a very long period of 10 years. So we told you that how difficult the initial days were, and that was the days before internet. So that time there was the NSF net in the US, which connected all the computers across the US educational institutes and started this. At the same time in Japan, a simultaneous exercise had started, and in Europe, of course, the World Wide Web had started with the CERN taking the initiative, and Tim Berners-Lee, who ultimately was known as the father of the internet because they set up the standards for the World Wide Web which we see today. Now, this National Science Foundation net was first with only 56 kbps circuits, and that was 1986. Soon the speeds increased to 45 megabits per second. That was by 90s. And then the CERN World Wide Web started, and with it started the 1G mobile network, which was about transmitting voice through analog signals. There were no digital signals then, there was analog signals. The 2G network was introduced only in the 1990s, and it was about transmitting voice and text messages, SMS and MMS. This was because the 2G protocol allowed voice and bits of data to be transferred digitally from one phone to another instead of through analog signals. So that is the time when the first digital transmission of data happened with the 2G, and it was different from the previous generation, which was 1G. And since its arrival, the data speeds have grown tenfold every 5 years. Cell phones became very popular, and models such as classic Nokia 3210 became symbolic of its time. So 1G network in the 1980s was not about transmitting data, it was about transmitting voice through analog signals. The 2G network in the 1990s was about sending voice and data through digital signals. The digital age enabled high-speed data transmission into cell phones. And then in 1999, I think Nokia 3210 was introduced, and it became the mobile leader in the pre-Apple era. So that was before the Apple smartphones were introduced sometime I think in 2007. Now we will tell you how we got the internet. The World Wide Web was introduced in 1991. Now this was introduced after a lot of experimentation at CERN, and they connected the personal computers of users across Europe. And it was a very time-taking exercise, and they created, importantly, a set of standards which made them unique. It was not only creating the machines, but it was the standard, the literature behind it, which made it different. And soon many of us had internet connections, but we were still dependent on an overground cable connection for the last mile connectivity. So that was a time before the Wi-Fi, when we were going through the data cables, and the system was totally unpredictable. Those were the early days of the internet area, and every time there was bad weather, the internet connection would get disconnected. So that was the pre-Wi-Fi days. See the video.
Let's go back to when things were simpler but a little noisy. 1G was all about audio calls. No texting, no images, just voice. You'd pick up your phone, dial the number, and start talking. But how did your voice travel across the network? Your voice was converted into analog signals. Yes, analog. These signals were sent to the nearest tower, called a base station. If the person you called was on the same network, your call would go directly to them. If they were on a different network or a landline, your call passed through the public switch telephone network, or PSTN. This system connected different networks together. From there, the call would travel to a mobile switching center, or MSC, which would route it to the right tower. Finally, the signal would reach your friend's phone. And voila, your call was connected. Since 1G used analog signals, you often heard a lot of noise or interference. The connection wasn't as clear as today.
So we were talking about how we got to the internet. Now the World Wide Web was introduced, as we know, in 1991. So many of us had internet connections, but we were still dependent on the overground cable connection for the last mile connectivity. So I remember when we were small, we used to have a storm and the internet used to go. Then we had to wait for about 2 days till the cable operator or the communications, whoever had the contract, that time I think Tata Communications had the contract over here where I was a kid, and I would wait eagerly for those guys coming on cycle, finding the fault. It used to take them 3 to 4 hours to find the fault, and then they used to do a patch-up job, and that was how it was. So every time there was a patch-up job, every time the next storm came, every time the internet was disconnected. So internet was the first casualty those days. Those were very early days, so you had the internet, that itself was a big facility, so there was hardly any place to complain, and nobody was listening anyway. So those were the early days. But we had at that time the 2G network also. The wireless network, which was known as the Wi-Fi for the home user, and that came almost a decade later. So once the Wi-Fi came, things improved dramatically, because that last mile connectivity problem had gone. So the Wi-Fi was something like a small router, and it could transmit and it could capture the signals from a place which was as big as a football field. So that was a huge area. So the Wi-Fi router, once it came, it helped improve the connectivity. You did not have to connect it in the last mile with wires. Now this Wi-Fi router, we may think that it is very small thing, but it is not very small thing. Even today, the Starbucks coffee or the railway stations, they all have this Wi-Fi router where it is free Wi-Fi. That is how they make these joints popular, because they have this Wi-Fi router. So it costs very little, but this Wi-Fi router is like a magic box in the internet world, and it has got enormous applications, and it helps you connect with data, and even nowadays with satellite data. So you just have to have the correct Wi-Fi router, and you can connect not only with the cables, not only with your mobile operator, but you can also connect with the satellites if you are not in a location where there is your cable communicator who is supplying data. So the Wi-Fi router is a game changer, and now the internet connectivity with 2G network, which was first intermittent, became stable, and soon, very soon, the 3G came in. So the 3G network improved the entire dynamics, because the speed was faster, the connectivity was very good, and the data transmission was faster, and we could look into the future, because this helped us develop the future Internet of Things. So that exercise started during the 3G age. It picked up speed during 4G, and it actually materialized into something where billions of data transmissions happens every day during the 5G era. And the wireless network, popularly known as the Wi-Fi for the home user, and the broadband network with 3G connectivity for smartphones, changed the game altogether. Although it took about 10 years to come, it eliminated the last mile wiring, and it was called the open spectrum era. It was like giving wings to the internet. A small black box called a router could distribute broadband connectivity to an area of the size of a football field. And that was magical. The technology of this non-descriptive Wi-Fi router has made it possible for all railway stations, all airports, and all cinema halls to provide access spots, hotspots of free internet connectivity at public places. The Wi-Fi potential will again be realized when direct satellite communication takes place with Wi-Fi, and they change the dynamics of the global telecom distribution system. That is very soon going to happen, because this router and the satellites have already connected during the Ukraine war in remote areas, and where there was no cable communication possible. It was Elon Musk who said that we will support Ukraine, which does not have a telecommunication system. And this was done free of cost by Musk. And it was something which kept Ukraine alive and in the hunt for the past few years. Of course, now Musk says that it's time to withdraw from Ukraine, and now the game is entirely different. They are going for a peace agreement, a forced peace agreement, which Ukraine may not agree to, but it is necessary for world peace. So these are the dynamics of internet which is shaking the world politics, which is changing the world politics. So why Elon Musk is so important in this global politics is just because he provided the telecom communication network through satellites to Ukraine. We will see about this much later in the chapter when we will talk about the economics of 5G network. Till then, see the video.
The amazing journey of data packets from a data center to your device forms the backbone of the internet. This data flow is governed to make the most efficient transfer of the data. It is apparent from this animation that this governing of the data from the source to the destination through such a complicated network is not an easy task. This whole process of the efficient flow of data from the source to its destination is known as routing. Let's try to understand routing through an analogy. Imagine a scenario where you are trying to reach your home from your office. The roads are full of traffic. In this scenario, you look up the road and traffic conditions on Google Maps. Based on the traffic situation and the road conditions, you take the easiest path to reach your home. Similarly, in routing, the decisions regarding the movements of packets are taken based on the state of network, and a device called a router makes these logical data decisions. The main purpose of having a router set up is to find the most efficient path through which the packets can be transferred from source to destination. Using very sophisticated algorithms, the router makes the decision as to which router or device the current packet has to be sent via. This procedure is repeated until the packet finally arrives at the destination. Routing can be divided into two categories, static and dynamic. In static routing, all the routes are set in a router manually. Thus, if there is any change in the network, there will not be any change in the route, unless someone manually corrects it. In dynamic routing, routes are set by the software according to the current state of the network. Network changes, such as link failures, traffic changes, and cost changes, will be updated at every discrete time step, and, based on this information, new routes will be decided at each time step. Dynamic routing is preferred over static routing because the routers update themselves according to any changes in the network.
Wi-Fi, as you know, the first Wi-Fi standards and routers were developed in the 1990s. But actually, the entire effort started long before that, a century ago. Wi-Fi is short for wireless fidelity. It is a wireless networking technology that allows computers, smartphones, tablets, and other devices to communicate over a wireless signal. Much the same way a radio can tune into a radio station signal over airwaves, your device can pick up a signal that connects it to the internet through the air. Indeed, a Wi-Fi signal is a high-frequency radio signal. It is an assortment of diverse technologies and hence does not have a single inventor. Now let us see who are the stalwart inventors who have worked on this. Hertz, Jagdish Bose, Nicholas Tesla, Lemar, Marconi, all have contributed to the founding concepts of Wi-Fi technology, after which it took 2 decades to evolve, with a dozen scientists and several organizations like AT&T and IEEE in the frame. So there was a scramble to claim that we have created the Wi-Fi router, but actually this router has multiple technologies assorted into it, and each technology has a different inventor. So we cannot say that X, Y or Z has created the Wi-Fi router. It has happened over a century, and it has happened in a very slow process with many creators who have worked at different parts of the technology. However, soon the Wi-Fi era and the excitement of the Wi-Fi era went away, because there was something even more exciting which came. And what was that more exciting thing than Wi-Fi? Then a stable internet connectivity. It was the arrival of the smartphone produced by Apple. In 2007, the iPhone created a revolution. So the concentration of people moved from the Wi-Fi router stage to the iPhone stage. So the iPhone became a gadget in the hands of millions, and each one learned to play with technology, to use technology in a very intuitive way, in a very interactive way. So you had not to teach them how to use it, because the smart technology was intuitive. People learnt on their own. Of course, there were YouTube videos who were teaching this, that how to use a smartphone and etc. But people learnt it on their own. And even today, most people learn how to use a smartphone on their own. So this is a magical moment in technology evolution, and soon Android phones came. So Android phones brought that technology to the masses, because iPhone was very expensive and Apple technology was expensive. So Google's technology was given, the software was given to all manufacturers who could use the Android software, and that democratized the sale of phones. So everybody could afford an Android phone, people who could not afford an iPhone, and the Koreans made it in millions, the Chinese made it in millions, and Nokia made it in millions, and everybody had a finger in the pie, and the software used was Android software. So the smartphone era, everything happened so quickly that soon we have about 5 billion smartphone users across the world, and that increased the data consumption. So everything was falling into place. By 2010, the data speeds had crossed 5 Mbps, and the worldwide internet traffic grew globally to 200 petabytes per month. Huge. And according to networking giant Cisco, smartphones now became very popular. There were billions of smartphones, and they had the capability to access the internet and take pictures as well as make calls and send text messages and data. Making pictures became a passion with everybody. It changed the user dynamics totally. The smartphone era came, and then came the age of selfies, of sharing your photograph with your friends, with your family, sharing your photograph in public places, in the Facebook or Insta pages, in YouTube, and making reels. So these all started, and this created a lot of data, and it required very high data speeds. And listen to this video and you will understand what really happened.
So, how are these popular gadgets changing your body and brain? If you're looking down at your phone right now, your spine angle is equivalent to that of an 8-year-old child sitting on your neck, which is fairly significant considering people spend an average of 4.7 hours a day looking at their phone. This, combined with the length of time spent in front of computers, has led to an increase in the prevalence of myopia or nearsightedness in North America. In the 1970s, about 1/4 of the population had myopia, where today nearly half do, and in some parts of Asia, 80 to 90% of the population is now nearsighted. And it can be hard to put your phone down. Take for example the game Candy Crush. As you play the game, you achieve small goals, causing your brain to be rewarded with little bursts of dopamine, and eventually you're rewarded in the game with new content. This novelty also gives little bursts of dopamine and together create what is known as a compulsion loop, which just happens to be the same loop responsible for the behaviors associated with nicotine or cocaine. Our brains are hardwired to make us novelty seeking, and this is why apps on our phones are designed to constantly provide us with new content, making them hard to put down. As a result, 93% of young people aged 18 to 29 report using their smartphone as a tool to avoid boredom, as opposed to other activities like reading a book or engaging with people around them.
Undersea cables, these are fiber optic cables that could transmit 4G services, were introduced by 2015. These undersea cables changed the game altogether. Across the continents, the data speed transmission was slow, but once the fiber optics cables were laid, and these were laid by the tech companies and by the cable companies, the tech companies including Facebook and Google, they had their own fiber optic networks, and this is how they have connected the entire world, and data speeds have now exceeded 500 Mbps, which was 10 times that of 4G. So what happened is that when this was introduced in 2015, there was no undersea fiber optic cables, but after 2015 the speeds jumped to over 50 Mbps once the fiber optics cables came, and then this was more than enough to have high quality videos, play games and stream video from the internet in an uninterrupted fashion. Now the 4G network was similar to the 3G network, except that it could carry more data and high speeds. And similarly the 5G network also was similar, but the data speeds went up 10 times. And because the data speeds went up 10 times, it could use the higher frequency or the broad spectrum part, and it changed the entire usage of the internet data traffic. And this has touched 194 billion gigabytes per month in a short period of 5 years. Unimaginable. Such speeds will make downloads and streaming content extremely fast. It will also enable current underexplored technologies like virtual reality and augmented reality to become possible. Now we hear about VR and we hear about AR technologies, but we don't know that when it will succeed. But these data speeds will make it succeed. It will provide the speed and the bandwidth and the reliability for autonomous vehicles, smart homes, smart cities to become a reality. So we learn about these smart cities, we hear that some smart cities are being developed. In Dholera, near Ahmedabad, a smart city is being developed. In Pune, a smart city is being developed. In various areas, smart cities are becoming a reality. So what are these smart cities? So for that you must understand the Internet of Technologies, you must understand the data speeds, and this is how you understand that where the world is moving and why you should learn more about these technologies and move ahead. The ability to connect to multiple data streams, to multiple devices, and at extremely lean, low cost price is magical. You are not using your technology powers to the full extent, and the day you start using it, it will mean much different to your lives. It will change your lives because it means that the information exchange through you, which is coming in from you and which is going out, increases much faster than what you were in the pre-toll area. I mean, before technology for all education, you were not so keen on exploiting these new technologies. But now, after you go through these toll classes, you will be very keen to know about these technologies, you will be very keen to learn, and that will change your life completely. And that is what we are trying to do, that you come to understand what technology is and how things will change in the world in the future. So let us look at this video.
The primary differences in 4G and 5G come down to latency, download speeds, base stations, cell density, OFDM encoding, and virtualization. The biggest difference between the two is latency, or the delay between commands and responses. 5G promises latency under 1 millisecond, while 4G latency ranges from 60 to 98 milliseconds. And with lower latency also comes faster potential download speeds. 4G maxes out at 1 gigabits per second, while 5G aims for up to 10 gigabits per second. That's 10 times faster. Another key difference are base stations, aka signal transmission. 4G, like its predecessors, transmits signals primarily from large cell towers. 5G uses small cell technology in order to deliver the speeds it promises. Small cells, about the size of a pizza box, will deliver high frequencies but have a smaller range, so they must be deployed more densely than cell towers.
So the smartphone became the ideal equipment to use all the infra which we had studied about previously. The internet, the Wi-Fi, the LAN, the data banks, the cloud server. We studied all this in the previous classes, and we will study it in future also, and they all connected billions of consumers worldwide. But there was a difference. Once the video technology entered, then the rise of the video and the streaming video, the gaming videos and other entertainment demanded the rise of data speed. It also ensured that millions of users came in. The users came in droves because everybody wanted to become a superstar. everybody wanted to create an Insta reel, everybody wanted to create a YouTube video, everybody wanted to express themselves. So this was platforms for expressing your opinion. Maybe you did not understand some things very well, but there are some things which you excelled in, and you use this skill to show what you excel in. So this was a completely different era altogether. The video took the human personality forward and placed it in the marketplace. That this is my contribution and enjoy. And a lot of people started enjoying such videos. They could be silly comedy videos to some, but they had millions of views. So they were very popular. They could be rant to somebody, but they were very popular. So it was a popularity drive, and it was something with video made the medium popular. The streaming video came into your lives. It made filmmaking much cheaper, much more economical, and people could experiment with low budget films with different actors instead of creating a mega budget production. So it helped a lot of things. It helped democratization, and it helped all of us to enter into a new world. Whether we like it or not, we can say that there is smartphone addiction, but at the same time we are all using smartphones, and we are all using smartphones smartly. Maybe all of us are not using it so smartly, but still they are using it smartly. I know an 80-year-old aunt of mine, she uses a smartphone, but that is a method of communication which she has. Otherwise she couldn't communicate because she stays alone. So she catches up with her friends and relatives through this smartphone. She sends you every day a message of hope, a good morning message. Every day she receives so many YouTube videos, so many music videos, and she distributes to her friends so many nice videos, and at times it is a little bit of spamming, but doesn't matter. It keeps her in touch. So whether it's a 18-year-old or a 80-year-old, it works for everybody. So let us not criticize the technology. Let us not only talk about smartphone addiction. Let us see what positives it brings. There is no technology which brings only negatives. There is no type of thing which has only a dark side. So it has a plus side. It has, for example, digital payments we start doing with the smartphone. So before that it was so difficult, and we would have to search change. Now whatever change you can make a digital payment, so you don't have to look around for change. Similarly, you are connected 24 hours with your bank. How was it possible before? You had to write checks, and those checks would take 2 days, 3 days to materialize. So now this entire thing has changed. The wallet is in your hands. You can go anywhere, and if you feel like paying, you can pay any time. So it has increased convenience by 100 times, and that is what is important. How internet has made things easier for you. How Internet of Things have made things easier for you. We will learn this in the next video in the next section, in the next class.
It all began in the 1950s with simple computer games. The 1970s brought arcade games like Pong, captivating everyone. In the 1980s, home consoles made gaming accessible. The 90s introduced 3D graphics and immersive worlds. Online gaming emerged in the late 90s, connecting players globally. The 2000s saw the rise of mobile gaming, changing how we play. Esports became a phenomenon with massive tournaments and fans. Today, gaming is a multi-billion-dollar industry.